We just said that divide by zero is a common cause of vertical asymptotes, things shooting to infinity or like that. So does divide by zero always cause a vertical asymptote? That's a good thing we might ponder. So go ahead and think about that. Can you come up with an example where divide by zero does not give a vertical asymptote? I asked this in class once and someone said, how about x over x? If you plug in x equals 0, at x equals 0, you get divide by 0, you get 0 over 0. What does the graph look like? Well, it's basically always equal to 1, except right at 0 when there's a hole. So it's the line y equals 1 except for that hole there. And that seems to not cause a vertical asymptote even though there's a divide by 0. Does this 0 over 0 make you think of anything else? Well, how about difference quotients? So we often write like f of a plus h minus f of a divided by h. Does that pretty much always give a divide by 0 when h is 0? So it always gives 0 over 0 at h equals 0. So it looks like we're in danger of a vertical asymptote. But does this tend to have a vertical asymptote? Well, let's try something straightforward. How about f of x equals x squared? Make it a little bit nonlinear. Sometimes when you use linear examples for stuff, magic things happen and things work out that don't work out for nonlinear stuff. So it's good to try linear stuff, but it's also good to try nonlinear stuff. Let's write f of a plus h minus f of a over h. So go ahead and write out the algebra for what this is involving squaring and stuff. It's an important exercise. So remember, it's a plus h squared minus a squared over h. You really have to have those parentheses because whatever you give the function, in this case a plus h, it will square that, not just the h, not just the a. And it won't just be a squared plus h squared. So this ends up being a squared plus 2ah plus h squared minus a squared over h. And what can we say there? We can say, oh, I have an a squared here and a minus a squared there. So then I get 2ah plus h squared over a. And what's that equal to? Over h. Let's try that again. And that's equal to 2a plus h, except at h equals 0, where this gives divide by 0, and this does not give divide by 0, right? If we plug in h equals 0 here, we don't get 0. We don't get divide by 0. So it ends up not having a vertical asymptote. Even though we started with a formula that looked like it would just give a divide by 0. What does this look like? Well, for any value of a, you just get 2a. So it's that line. Wait, sorry. What's our axis here? We're thinking of this as a function of h, so this should be the h-axis. And if a was positive, we would just get 2a. Wait a minute. We're getting 2a plus h, so it should actually be slanted. with a slope of 1 because there's a 1 on the h. Okay, should I go back and erase that from the video or leave it to show that we can make mistakes and recover from them and discover interesting things? All right. So again, we have an example that you don't always get a vertical asymptote when you get it divided by 0. I said difference quotients often don't give a vertical asymptote when you get it divided by 0, but did I say they never do? Well, it turns out they can if the function you're taking the difference quotient of has an infinite slope at a particular point, which happens with like x, square root of x, for example, or cube root of x. We won't worry about that right now. Another interesting formula is sine of x over x, which looks like this. It has a hole here at 0, because sine of 0 is 0 divided by 0 for x, and it does something like that. Does that have a vertical asymptote? Nope. Even though it looks like divided by 0. At x equals 0. This function itself is called sinc, spelled like that, and it's useful in signal processing, so it's kind of a handy function. But it's also interesting, we can relate it to difference quotients. Can you imagine this as a difference quotient that is coming from a difference quotient? Difference quotient usually has this minus that over something, right? We could think of it, so what am I subtracting here? You could say I'm subtracting 0. What's another way of getting 0 that's related to sine of 0? Usually a difference quotient has x plus h or a plus h there, but I don't have a plus, or I could say I'm adding 0. So I could say this is sine of 0 plus x minus sine of 0 over x. So 0 plus x is just x, sine of 0 is 0, so this reduces to that. So that's a difference quotient for sine, asking what the slope of sine is at 0. And it's this value here, these two sides are sneaking up on y equals 1. So the slope of sine at 0 turns out to be 1, even though there's a hole in the graph because of the difference quotient.